Hi, I'm Hui from City University of Hong Kong. I'm happy to share our work ProObjAR, prototyping spatially aware interactions of smart objects with AR-HMD. This is a collaborative work with Jiaye Leng, Chufeng Xiao, Professor Lili Wang, and Professor Hongbo. Let's start with a small action, lift to wake. It is now commonly used in our daily life. This interaction paradigm, spatially aware interaction, is designed for smart objects to enable ubiquitous computing. It covers spatial movements of one smart object and spatial configuration among multiple cross or networked objects. However, prototyping such interactions remains challenging since there is no ad hoc approach. Recently, AR prototyping brings new possibilities, but most of the tools focus on prototyping AR experience from the perspective of human instead of the spatial interactions of the objects. Compared to very recent work, Gesture AR, we want to provide designers with a solution to prototype real object spatial interactions. So, in our motivation, the real-world object will be a driver, virtual content will be a representative of ultimate functions. To better understand spatial object interaction design, we conducted depth interviews with 4 design experts. We found the challenges of the existing prototyping approaches. They are not general to be used in complex and various usage scenarios. To specify interactive object behaviors, programming skills are usually required, so it has very high entry barriers. To make an interactive prototype, the designers must traverse multiple tools, so an ad hoc tool is needed. Besides the challenges, we also found the common and individual expectations for an ideal prototyping tool. Please refer to our paper for more details. To better understand spatially aware interactions, we explore a design space from 4 dimensions: quantity, proximity, movement form, and interaction space. These 4 dimensions categorize spatially aware interactions. Based on the design space and interview findings, we formulate a spatial interaction model. It describes the input spatial event and the output virtual effects for prototyping spatial interactions. We divide input into discrete event and continuous event of the smart objects, and output into discrete effect and continuous effect of virtual assets. Such a paired input event and an output effect compose a discrete or continuous input-out interaction. Continuous input-out interaction can be further categorized into synchronized and twin interactions. To support prototyping such interactions, we design and develop ProObjAR. It provides single user with an AR-HMD interface. Users can follow an input-out triggering workflow to define the input events, output effects, and their relationships from a visual programming interface for various usage scenarios, and test the results through real-world object manipulation in situ. Here we use an example to show the workflow. A designer wants to design a smart charger. When the phone is moved to the charger, it will be charged. So the user can first attach an AR marker to the phone to get the pose of the 3D object. And the user moves the phone to the target position and presses the event button to create a position event, visualized by a square proxy. Then the user can drag a battery's asset to the scene, scale and rotate it, and assign a peer effect to it, and then moves it to the target position. Then the user creates a connection between the event and effect by dragging a line between proxies. Finally, the user can test the results by moving the phone to the specified position to trigger the battery appearing effect. Here we show another example. The user wants to create a twin orientation event by rotating the cup to 2 directions. Then, drag a sound asset to the lamp. And assign a twin opacity vector to the asset by specifying 2 opacity values from the slider. After that, the user can drag the lines between the event and effect proxies to create connections. Finally, the user rotates the cup to change the light brightness. The user can create a plane to place assets and create assets by 3D sketching. The asset, event, effect, and mapping can also be deleted. We also provide a focus mode to only display connected lines of the interested objects. To evaluate ProObjAR, we conducted a preliminary usability study. We asked participants to create free-form prototyping results using our system from a 2-session process. Their prototyping results cover various usage scenarios including facility, alliance, device function controlling, cross-device information exchange and synchronization, information discovery, display and presentation, and personal health and living management. Next, I will show you some result videos. When the user places a flower into the vase, it will play music and project a text message "I love you" on the background. The smart speaker will play different music when it faces different directions. The user moves the cup to a certain location and the cup will be heated. The laptop will transfer files to the phone when the phone is placed closely to the laptop. The 3D pose of the phone and a 3D model is synchronous. The user moves the phone as a slider to adjust the light position in the light tape. The user moves the watering pot to determine the watering area. The user uses the pen to control the fan direction. When the user holds a piece of paper facing the printer, the content on the paper will be copied with no need to put the paper in the printer. The desktop will check the cleanliness of objects placed on it. If all the objects are placed facing the same direction, it will display a good sign on it. The user uses the pen as a pointer to project the cursor on the projection screen. The size of the projected content is changed according to the distance between the phone and the wall. To sum up, we identified the prototyping challenges from an empirical study, explored the design space of the spatially aware object interactions, formulated a spatial interaction model, and proposed ProObjAR system for in-situ prototyping. If you have any questions, welcome to contact us. Thank you.